All right. So let's start. And quick question to you all. Who all could see what are the things that we're going to learn today? So today is the Super Bowl, right? So I thought of making sure that we'll learn enough, but we'll try not to pick up a topic which is complicated. Again, I'm still going the sequence. I have picked up the third unit of 6th grade, and then continuing with the journey, right? So here we'll talk primarily about the number line. Number line, different things on the number line. How do you deal with negative numbers? How do you understand or interpret an opposite number? How do you deal with identifying different points on the number line when it comes to locating a rational number or a whole number or a negative number? And then how do you deal with finding out the difference between different types of numbers that you deal with, and how do you relate that with a number line? Okay. So it could be new for some of you, it could be known to many of you, but still we'll try to skim through this very quickly, and then towards the last 20 minutes I would want to take feedback from you guys to understand if any of you have any particular topic that you would want to learn. Let's say for Ritika, this is a first class for her, and I would want to learn from her if there is any particular topic that she would want me to cover in those last 20 minutes, okay? Because this number line thing we can cover really quick, okay? Yeah. So Ritika, request to you, beta, you can think about any particular topic that you have in mind, which we'll talk about in the last 30 minutes, okay? Or 25 minutes.
Sure. Okay. Is my mom here?
Your mom is here?
Sure.
Alright. So,
Yeah.
first of all, let's talk about what is our understanding of different types of numbers, and then we will go to the next step. Give me 10 seconds. So, in the last class we talked about a number line. We talked about a number line, and we talked about what is a natural number, what is a whole number, what is integer. So let me put these numbers here. So yesterday when we were talking about it, we discussed that all the numbers from here to here, basically starting from 1, going all the way till any number that you can think of, these are called natural numbers. If you include 0 also into it, this becomes whole number. And then you include negative numbers also, it becomes integers. And how you will represent this is this way. Advic, not needed. If somebody has to go for the Super Bowl in between, you guys can safely, happily drop off and go. But let's not discuss about the Super Bowl event within the class. Whoever misses part of the class, you can always watch the video of the class to catch up on what we learned after you left. Okay? So, but let's make sure that till you guys are in the class, we are not getting distracted by any other information. Now, look at the visual side of it. If I look at the smaller circle, this is my circle which says this is my natural number. And if I add 0 also, this circle became whole number. This circle retains all the number in the whole, in the set called whole number. And if I look at this bigger circle, meaning natural number without a 0, including 0, this bigger circle became whole number, which includes the natural number inside it. And then here you have negative numbers, and this became this bigger circle, integer. This bigger circle is integer. So you can look at by pictorially, if you look at it, this is how this is. This is a baby circle which is inside this one, which is called whole number, which has positive numbers plus 0. And this, the largest of the three circles that you see on the board right now, that is integer, which includes whole number as well as natural number inside it. That would be a way to interpret this one. Now, there is one more thing that we have not counted yet. We are only talking about the numbers which are complete, which doesn't have any decimal or fraction to it. So when you include that, now you look at it. Between 1 and 2, there will be another thing which is 1.5. Or there could be 1.25, there could be 1.35, there could be 1.75. All those are between 1 and 2. Those are nothing but your fractions or decimals. So you can say this is 1, this is 2, this is 3 by 2. Here it will be like 5 by 2, which is 2.5. Here it will be like 7 by 2, which is 3.5. And you can just go on. So basically, when you look at the whole numbers, and then if you include the fractions also, then the whole set becomes more complete. The whole number line that you are looking at, it has all possible varieties of numbers, which is whole numbers, natural numbers, integers, and then you have fractions also. So the superset, which includes all possible numbers that we deal with, that is called rational number. Now, by definition, a rational number is nothing but something that can be represented as a fraction. Now, the point here is, my whole number also I can represent as a fraction. 3 I can represent this as 3 by 1. So that's why rational number is a superset which includes everything inside it. Meaning, any and every number you can represent as a rational number. And that becomes a superset. Yep. So let's deal with something called negative numbers. So you saw that, okay, if you are looking at a number line, this is your 0, this side you have positive values, and this side you have negative values. So, first thing first, what is our understanding of a negative number? What do we exactly mean by negative numbers? I would need 3 to 4 definitions. I'll come to you guys. I just need a sip of water. Just give me 10 seconds. Yep. What is a negative number? Advik.
A negative number on a number line is a number opposite to a positive number.
Okay, opposite to a positive number. Or if you call this as the origin, negative numbers are the numbers which are on the left side of the number line. Yeah? Yeah, Rav, tell me, what is your understanding of negative number?
I understand as a negative number, same as Advik's understanding is the opposite, but it can also be verified as an integer, a rational number, and an irrational number.
Okay, the last part you said, that did not add any value, so I will keep it there. I was talking about negative number, so rational, irrational numbers, I will keep it out of context for now. Let's see what Nihan has to say.
Numbers that are less than 0.
Numbers that are less than 0. If I have $5, that is a positive value. If I owe somebody $5, that's a negative value. Yeah? That's the practical relevance of that one. Any other definition? Anybody else? Moira? Vasundhara, Thanu. Deekshita, Pranav, anybody? Yep, Aditya I've already told. I have to let everybody speak. No other definition? Yeah, Gitesh.
It's like owing someone a biscuit, a single biscuit.
Okay. A negative thing is it's like owing something. Okay. So anyways, so today our discussion would be revolving more around the number line. So that's what we'll focus on. So if you're talking about a negative number you will say these are numbers which are on the left side of the origin or opposite to the positive numbers, as many of you said. Okay. So that's the basic definition of negative numbers. Now, if you say what is the opposite of a positive number? So if somebody says, okay, 8, what is the opposite of 8? So you're talking about this being your mirror, and if you say 8 will be somewhere here, maybe 1, 2, 3, 4, and this is 8. So opposite of this will be a mirror image of this on the other side. -8. This will be your opposite number. Okay. Similarly, other thing that you would want to consider or keep in mind is, if you're talking about number line, you're always talking with respect to the whole numbers or integers. But then you have to always remember that between any two numbers, let's say 3 and 4, there could be different values possible on the number line. Let's say if I zoom in and look at 3 and 4, this is 3 and this is 4. I can literally break this into 10 parts, and this will be 3.1, 3.2, up to 3.9 and then 4. If I zoom in further, between 3.1 and 3.2, let's say this, I'm talking about 3.1 here and 3.2 here, and breaking this, I'm just zooming in the number line. So this becomes 3.11, 3.12, 3.13, 3.14, and goes all the way till 3.19. I'm not happy with what I've done so far. I'm further zooming in between 3.11 and 3.12. So I have 3.11 here and 3.12 here. And so this becomes 3.111, 3.112, and goes all the way to 3.119. Okay. So this is the same number line where I'm zooming in. Okay. And going to the 10th place, 100th place, or 1000th place of a fraction of the distance between two consecutive numbers. If you look at this one, what did I do? Between 3 and 4, I went to the 10th fraction of this, 3.1, 3 and 4. So there is a term for this. Let me tell you what exactly it is. Yeah. So this is nothing but, this is the 10th of two numbers. This is 100th of two numbers. This is 1000th of two numbers. Okay. So between 3 and 4, if you look at this, from here till here, basically you have got 10, every 10 is into 10, this became 100, and every piece of that got split into 10 pieces again. So this became, from 3 and 4, you got 1000 places, or 1000, what do you call, 1000 values between 3 and 4. So this is just, don't visualize a number line as a number line where you only have full numbers. Okay, you can also visualize this as a number line where you can split any two numbers into nth level of detail depending on how granular, how detailed you want to go. Is this part clear so far? I'm just, in summary, what I'm trying to say is, you can have a point here which says 114 by 1000. What I have done here is between 1 and 2, whatever distance I had, I split that into 1000 pieces and I picked 14 out of that. And that will be my 1.14 by 1000. No, it will not be 1.14 by 1000, it will be 1.14 by 100. So I just split into 100 pieces, I picked 14 of the 100 pieces, and that's the point between 1 and 2, which is 114 by 100. So these are the ways you can find out nth fraction of a number between two consecutive numbers. I will not go into my details for now. This is not something very tricky, very difficult. It's just about knowing that how you can split two numbers into multiple pieces, and so that you can locate a decimal point on the number line. Okay, and probably after some time I'll teach you guys how to draw or locate a irrational number also on the number line. Something like square root 2. How do you find that point on the number line? And I'll help you guys figure out how do you find that and how do you draw that, how do you locate that point also. Okay, using mathematical instruments. So, but this was all about the number line, which I wanted you guys to visualize or understand that if you have a number line, what is your understanding? How do you identify or locate fractions or decimals? How do you understand the difference between negative number and the positive number? How do you find a negative number as an opposite of positive number or vice versa? So if you come across a question which says, find out the opposite of -8. So opposite of -8 would be something on the positive side as a mirror image. So basically what you will end up doing is you have -8. Whenever you have to find an opposite of something, you have to multiply that by -1, and that will be your positive. That will be your opposite. So if your question is find out the opposite of 8, opposite of 8 will be 8 into -1, and whatever that value is, that is your opposite. If you have to find out the opposite of -21, you have to just look at multiplying -21 with a -1, and whatever you get, that is +21. So that is the opposite of that number. If you have a fraction, let's say 3.165, and somebody says find out the opposite of that, the opposite of that is nothing but -1 times this number. That's it. And whatever you get is your opposite. Yeah, Advik.
What if it's absolute value?
I'll come to that. So now, we looked at the number line, we looked at numbers on the positive side, we looked at the numbers on negative sides also. So let's come back to the number line again and look at it with a different perspective. That is where we'll be able to understand or relate what exactly is an absolute value on a number line. With respect to a number line, this is 0, 1, 2, 3, 4, -1, -2, -3, -4. Okay. So now we know this is the positive, these are the positive values, these are the negative values. If I say a point this, 2, this is 2 units away from the origin, the 0. This is 2 units. Okay. But here we are saying this is on the positive side. If I say -3, what we are saying, if I have to look at this point, I will say this is 3 units away from origin on the negative side. Yeah? Arif, hold it, I'll come back. When I am explaining something, my earnest request to you all would be, let me complete and come to a logical point before I am getting bombarded by the next set of questions. Okay? I am not skilled in doing multitasking. I do one thing at a time, and that's what I prescribe everybody. Okay? Alright, coming back to this one. Now, if I am talking about -3, I am talking about 3 units away from the origin, but in the negative side. Now, when you talk about absolute value, you have to look at, let me define this, 2 units away or apart from origin in right side, right direction, right side. This is 3 units apart from origin in negative side or left direction. Okay, so this 2 is 2 units away from the origin on the right hand side. This -3 is 3 units away from origin on the left hand side. Yeah. Now when you talk about absolute value, what you do is you just forget about the direction part. This just tells you the absolute distance from the origin, be it on positive side or negative side. This is absolute distance. So that's what is the absolute value. When you just say how far is that point from origin without worrying about positive or negative value. Or mathematically you will say, okay fine, if I have a -4, what is my absolute value? So based on what I said just now, it is 4 units away from this. So I'll say 4 is my distance, or 4 is my value, and I'll just ignore this negative part. That is how it becomes the absolute value. So absolute value on a number line simply means how far it is from the origin, regardless of whether it's in the positive direction or negative direction. Does that answer your question, Advik? If you have a 3, absolute value is 3. If you have a -3, that also absolute value is 3. So this is when it doesn't differentiate between the sign. It just treats them one value, ignoring the sign part of it. Yeah? Is that okay? Did everybody follow me? Yeah? Yeah, Arab. Now what's your question?
So when you said 3 units up or 3 units down, there's like a question where it says like write the equation down of the arrows.
Are you clear about the question first in the first place?
Never mind.
No, so see again, I am not very intelligent, okay? I will only understand once things are explained to me in a very simple, clear way. Or you will give me a question which I can read 3, 4, 5 times to be able to solve it. Half-cooked questions don't mean anything to me. Think about it. Once you are clear about the question, let me know. I'll certainly try finding out a solution to that. Okay? So we talked about what is number line, what different types of numbers, what do we mean by opposite of a positive or negative number, how do we represent decimals or fractions on a number line, what is absolute value. Sorry. What is absolute value with respect to a number line. So that is all we had planned for today in the class. Now I will let all of you go who have plans to watch Super Bowl. I would not want to be a spoiled sport. However, there is an option open for Ritika to understand if she wanted to learn something in the class today. Okay, so Ritika or Sundara, whoever wants to continue, they can continue. Kids who are excited to watch Super Bowl, I would let you guys go, have fun, and you will have to watch the video of the rest of the class any which way. Yep. Because whatever I teach, there will be assignments related to that also. So it will be a quick check on whether you guys understood by watching the video or not, and then we'll see how do we take it from there. All right? Yep. So over to Ritika. Now Ritika, tell me which topic you would want me to start to develop for you. Anything that you would want me to give you a quick jump start.
There's not really anything like. Wait, can I say like anything? Like in.
Yeah, of course. Anything in maths.
Well, I'm really like geometry, I guess, in school, but there's not really something like maybe like statement reasons and like stuff like that, maybe.
Okay, so let's start with geometry. Let me see. I will go from beginning. I'll go from scratch and go to a certain point and see where I'm able to add value. Okay.
Okay.
Alright. So when it comes to geometry, geometry is one of the easiest subject in my mind, and it will become easy for all of us provided we are able to visualize it correctly. Okay. So that's the precondition. So my geometry starts with something as boring as possible. This is a line which has no starting ending point, just a direction. Then you have a line segment which has a starting point and ending point. And then third one is a ray, where it starts from one place and it has a direction. Something like a torch, from where you turn it on, your light goes from, let's say, people are tired of seeing my phone, but anyway, I'll do it one more time. So if you look at this, light is starting from here and goes in this direction. If I'm keeping it this way, if I turn it this way, it will go in that direction. So ray is something, light is originating from here and going in the direction that I am keeping my phone in, right? So this is called ray. So line, segment and ray. This is the first thing. Now line has only direction both ways. Line segment has a starting point and ending point, meaning there are 2 points, you just join them, that's a line segment, which is a fixed length, starting point, ending point, and then you have a ray. So this is one part of it. Now then, this part has no problem, right, Ritika? I'll keep on asking you in between, just to make sure that I'm not rushing through things, okay?
Okay.
Then, I'm not happy with 1, so I went to 2. And this is when I start dealing with angles. When 2 lines or line segments meet at a point at certain inclination, this inclination between them is called the angle. See, my angle is small, my angle is getting bigger, big, yeah. And this angle can be very small, like what you see right now, or it can be like this, or it can be like this. So this angle is less than 90 degree. This angle is exactly 90 degree, and this is more than 90 degree. These are the 3 possible variants that we deal with. The angle which is less than 90 degree, anything which is small, acute angle, yeah. Angle which is 90 degree, this is called right angle, because this is the right positioning of the ball. Imagine right angle as representing 2 walls. Look at your floor and you will see that your floor and the wall next to it in this position always. This is right. If the wall is like this, it's going to fall. If the wall is like this, it's going to fall. Yeah. So that's why when it is perfectly aligned or perpendicular, when it's making 90 degree, that's when it's supposed to be right. So that's why it's given the name right angle. Yeah. And then when the angle is more than 90 degree, that's what I have told Gitesh so many times, that when my wall is about to fall on my neighbor's wall, that is obtuse angle. Yeah. So there are 3 varieties of angles that we deal with. Yeah. So we started with 1 line segment and ray, and then when we were not happy with just 1, we went to a situation where we had 2 lines or line segments meeting at a point with certain inclination. And there are 3 variants of the angles that we deal with. Yep. So far so good? Ritika, are you with me with
Yeah, I'm okay.
Okay. Now 2 is not enough. We go to 3. And that is where we end up dealing with triangles. Now if you look at triangles, we are essentially talking about 3 sides and 3 angles. That's what makes a triangle. So you have triangle which has 3 sides and 3 angles, and this is the first closed shape that we end up dealing with. Meaning a triangle has 3 sides and 3 angles, and it's a closed shape. If I have something like this, it's not a triangle. This is open. Anybody can come in, anybody can go out. This is not a triangle. So when we're talking about all the shapes that we'll talk about hereafter, they'll be all closed shapes, and we are starting with triangle, which has 3 sides and 3 angles. Now, if you look at the property of the triangles, yeah, Dikshita. Okay. So when you look at the property of the triangle, essentially, what is my property? My property is not the money that I have. That is not my property. My property is how many hands I have, how many legs I have, how much hair I have, what is the power of my glass. Okay? All that put together is my property. So same way, basically visually whatever you see, that is my property. So here, these sides and the angles are the property. So that way, based on the sides and angles, you have different flavors of it. Sides and angles. These are the 2 things which will decide what are the different forms of triangles we will deal with. If you look at sides, there are 3 possibilities. One situation when all the 3 sides are same. This is nothing but equilateral triangle. When only 2 sides are same, this is called isosceles triangle. And when all sides are different, this is called scalene triangle. Yeah? Are you with me so far?
Yeah.
Is everybody with me so far? Is some, I don't know if that's the right sentence or not. Or some of you tired of hearing the same thing again and again? There might be some people, but that's okay. Okay. Now, so based on sides, you have 3 variants. Equilateral triangle, when all the sides are same. When only 2 sides are same, that is isosceles triangle. And when all the sides are different, that is scalene triangle. Now, based on angles also, you can categorize them into 3 parts. When all the angles, when we looked at the angles, we looked at 3 variants of the angle. Acute angle triangle, right angle, when we looked at angles, we looked at 3 variants of the angles. Acute angle, right angle and obtuse angle. Meaning, when all the angles are less than 90 degree, that is called acute angle triangle. When one of the angle is 90 degree, that is called right angle triangle. And when one of the angle is more than 90 degree, that is obtuse angle triangle. This is right angle. Since this triangle contains a right angle, that's called right angle triangle. This is obtuse angle. Since this triangle contains one obtuse angle, this is called obtuse angle triangle. And since all the angles are acute angle, that's why it is called acute angle triangle. Yeah? So the basic definition that you have to always remember is, if all the angles are acute angle, then it is acute angle triangle. But in case of right angle and obtuse angle, you have to have only one. Only one angle is right angle or obtuse angle for this to be called right angle triangle or what is the question?
Are all triangle angles supposed to be 180?
No question about it. So basically that's what I'm saying. So some of you have already gone through it. So there'll be known facts, but I will go in a certain flow. Okay. So please don't jump the gun in between so that it disrupts the flow. All right. Now comes. So basically we just looked at what is a triangle, what is the categorization of triangle based on the angles or sides, and now comes some more facts. If you are talking about any triangle, sum of all the angles will be 180 degree. And this is not what I am saying. This comes from a magic formula called 2n minus 4 into 90 degree. This is a generic formula that all of you need to remember. This guy tells you what will be the sum of all the angles inside a shape, depending on the number of sides. Here in triangle, I am talking about 3 sides. So I will replace n with a 3. And this will tell me what will be the sum of all the angles in a triangle. 2 3s are 6 minus 4 2. 2 times 90 is 180. So this formula tells me, this magic formula tells me that sum of all the angles in a triangle has to be 180 degree, and I follow this blindly. So if any of you or anybody in the world tells me ever that there is a triangle whose sum of all the angles is 179 or 181, I would not agree. This is something written in stone. You can never ever have a triangle where the sum of all the angles is not 180 degree. Okay? So now if you want to check, a rectangle has all angles 90 degree. 90 degree. Sum of all that is 360 degree. Put in this formula and see if you get the same value. Here number of sides is 4. So 2 into 4 minus 4 into 90. See what did you get? 2 into 4 is 8 minus 4 is 4 times 90 is 360 degree. So this magic formula works. Yep. Ritika, is this?
Yeah, I got it.
Yep. Now, so we have seen so far the basic properties of a triangle, and we are trying to go to the next level of information. So, but before I go in a certain flow, anything in particular, Ritika, that you would want me to start with, or I can just go with this flow?
But you can just keep going, right? This is fine.
Okay. So see, my way of teaching is like telling you a story. Started with 1 line, went to 2 lines, then 3 lines, then we'll go to 4 lines, and we'll keep digging through it one by one. Okay. So what we'll do is, since you mentioned geometry as this thing, we'll use geometry as a filler in every class. Okay. So whatever I plan to teach, initial 40 minutes I will teach that. Last 20 minutes I'll keep for geometry, because whatever I have explained so far, most of the kids in this class, they have gone through it. But now I'm going to do a double click on this to explain more detailed things about it, okay? Which will be beneficial for everybody in the class also. So every class of yours, not only for Ritika, but for everybody else, would be a combination of 60%, what is that, Arif? Put it down. 60% or 70% of that would be a topic for the day, and 30% we'll keep for geometry, so that we keep it interesting. Geometry is one of my favorite subjects. Geometry and trigonometry is Arif, keep it down, madam. That why you have to distract the class by doing something not needed. So geometry and trigonometry are my favorite subject. I'm not saying algebra is not, but geometry, trigonometry, and pre-calculus. These are 3 of my most favorite subjects. Okay. So that's why when you gave me a reason to talk about geometry, I'll use that as an opportunity. But is that okay with everybody in the class? Let me check with Bhuvan. Are you okay with that? Vasundhara is fine? Yeah? Okay. Now, so Hiranya, you okay with that, right? Sometimes teacher imposes certain ideas. If you don't like it, raise your voice, okay? You can say that, sir, maybe from next week. That also works, okay? I'll make sure that I don't teach it for myself. I'm teaching it for you guys. Alright, so coming back to, we talked about different types of triangles. We talked about sum of all the angles and all that. Wonderful. Now comes the next thing. This is where, so before I go to the shape which has more than 3 sides, let's stick to 3 sides, which is triangles, and do a little bit of more mining of that. So what do we mean by that? So now we know that, okay, any triangle that we talk about will have 3 sides and 3 angles. Wonderful, understood. No problem. But what next? Now, any shape that you talk about, what is that? None of the pens are working. These are low budget pens? No, they are working. Okay, fine. Any shape you talk about, there is a difference between this shape and this shape. This shape. Why? Because if you look at them all, this is taking more space on the board. This is taking lesser space. Even less space. Least space. when you say how much space a particular object is taking on the board, that is nothing but the area of that shape. So now mathematically I will say this triangle has maximum area, or this triangle needs this much area, this triangle needs this much area, this one needs this much area. So area is nothing but the space taken by that particular object on the surface where I am trying to draw it. Imagine in your house you have a window which has a triangle at the top. I don't know if your house has a window like this, but I'm assuming, okay? If not your house, maybe a neighbor's house has a triangle at the top. So based on what you have learned, this is the area. How do you relate that practically? If you have to cover this with a glass, you will know the size of the glass that you would need for this window. That is your area. The size of the glass that you would need for that window, that is the area, right? So that is how we relate. How much space it takes, how big that piece is, how much space you will need on the ground for keeping it there, right? Let's say if my feet is very big, can I stand on a nail? No, because nail has only this much area on the tip and my feet is this big. What will happen if I stand on this? It will just pierce my feet. I'm not saying that makes you guys happy, but I will not be happy about it for sure. Standing on nail, right? So what it means is the area of the nail is much smaller than the area of my feet. That's why I'm not going to stand on this one. Same thing will apply here. If I'm talking about area of this window, I need at least this bigger glass. If I put a smaller glass, that will be of no use. It will keep on falling. If I put a bigger glass, that will look weird. Correct? That will not look like the right fit. It's like me wearing a triple XL. I'm still fat, but I can manage with XL. If I put triple XL, that will look weird, right? That will look like a misfit. Same thing here. If I'm talking about this much area, I need this bigger piece for covering this. That is the space it takes. Yep. I gave all lame examples just to make sure that you guys find it relatable. Yeah. Now, so area, be it an area of a triangle, be it an area of a circle, be it an area of a rectangle, doesn't matter. Area means the space that particular object takes on the surface where you are keeping it. Are you guys with me so far? Everybody. And I'll keep on calling out Ritika's name.
Yeah, I'm good.
Okay. Alright. So sometimes even lame jokes make people smile. So that's okay. I could sense that Ritika is laughing behind the screen because I gave her some interesting examples about me being how fat. But that's okay. Now coming back to, so area we understood. Area of any shape is nothing but the space that it takes on the surface. Now there's another thing that we will keep coming across, that is called perimeter. Perimeter is nothing but the length of the boundary. Meaning, if this is my farm, how big the wire I need to barricade my farm, that will be my perimeter. Basically, length of all the entire boundary. So this side plus this side plus this side together will be my perimeter. Be it for a rectangle, be it for a triangle, be it for a circle, everything. If I talk about perimeter, I am talking about the length of the entire boundary. If I am talking about area, I am talking about the space that it takes. So that's the basic difference between the two terms that you will come across 1,000 times, if not 10,000 times. Okay. So that is the basic understanding of area and perimeter. Now let's jump into it. And so today we will learn about, before I tell you guys the formula for area, perimeter you will just measure the length, that is fine. Arab, you have to put your hands down, you don't have a question to ask. Right now I'm not going to entertain any question. Yeah, tell me.
That was my bad. I just did on accident.
Okay, that's fine. That's what I'm saying. This is not a chance for asking question even. Alright. So, before I talk about the area of a triangle, I wanted to tell you guys or teach you guys some of the basics that would help you find out the area of a triangle or derive the formula for area of triangle, and that revolves around the fact called a term called congruence. Do you know what is congruence? Not a question for the kids who have been in the class before. It's a question for Hiranya and Ritika, and also Nihan. What is your understanding of congruence? What exactly do we mean by congruence in practical terms?
I know congruent.
What is congruent? Tell me.
Kind of forgot, but I think it's like equal in different way.
Okay. Let's see if Hiranya and Ritika have a point of view. No, Advik, not a question for you. Mhm.
Maybe like identical, like the same shape, but like.
Exactly. It's identical is the right word, the most appropriate word. I mean, that's one word that defines congruence. If I say this triangle, yeah, Gitesh, not a question for you either. Okay, if I say there are two shapes, they are congruent, we are talking about they being identical or a mirror image of each other. Okay? So, if this triangle and this triangle I say congruent, that means they are exactly identical, they are mirror image. And what would that mean in mathematical terms? Meaning they will have matching side. So this side matching, this side matching, this angle, this side also matching, and then this angle matching with this angle. Meaning, since these two sides are matching, the angle between them will also match. Similarly, this side and this side matching, this side matching, the angle between them will also match. And third angle has to anyways match. Okay? So, if I say the two triangles are congruent, meaning their three sides are matching with the corresponding side and the three angles are also matching. And also, the area of this triangle and this triangle will be the same. They are identical. There is no way you can differentiate them. There is no way you can find even tiniest of the difference between the two. Okay? Every property matches. Now, this is just the theory part of it. Advik, no question. No time for a question. So this is called time management. If I let you guys talk, I know how talkative the class gets, and that becomes unproductive. I don't like unproductive stuff. So I will let you guys answer when the time comes. Or I will let you guys ask a question when there is a need. Because I know your needs better than you guys. Alright, coming back to the point. So I said congruence. Everybody understood what is congruence. Congruence means something which is identical. Wonderful. Now, that is not enough. When you talk about congruence of triangles, there are 4 theorems. Now let me see who all has seen these 4 theorems, who all remembers these 4 theorems, and who can tell me about this. And everybody who is raising hand, I will choose who has to answer, and you will only talk about one theorem, not all 4. Okay? So, let's start with Ritika first. Yeah, Ritika, tell me what you know about these theorems. Tell me one
About all of them?
Maybe one of them. You can start with one of them.
Like, should I just say what they stand for?
Yeah, that's fine.
Like the first one is side, side, side.
Okay.
And that that means like that like 2 triangles are congruent because they have like the same side.
Okay.
Should I keep going?
Okay. Let's see what Gitesh has to say. You talk.
Can I take the second one?
Yeah, please.
Angle, side, and angle.
I lost you for 10 seconds. Say it one more time.
Oh, angle, side, angle.
Angle, side, angle is understood, but describe that a little bit more.
If you have one triangle, then like
one of the angles is same, and then the other side is the same, and then the angle is the same, that means both of the triangles are same.
Are congruent. Okay, let's see if Dikshita can.
Hello?
Yep.
Anyone
No, I heard you, Gidesh. I'm going to the next person. Okay. So let me see. Pranav can describe ASA differently.
ASA is angle side angle, and it's used for if they're two congruent triangles, and then when you only have one side.
Okay, so let me describe it. The way I wanted to hear it from you guys was that two triangles will be congruent if both of them have two angles matching and the side between the angles also matching. So two angles and the side between them. The order matters, okay? So that's why you will say if these two triangles are supposed to be congruent, then these two angles, these two pair of angles will match, and the side between the two angles is also matching. Meaning, you don't have to say first one said, if all the three sides, this side is equal to this one, this side is equal to this one, this side is equal to this one, then these are congruent. But this theorem says that you don't have to match all the sides. Just two angles and the side between them. If they match, you are fine. Okay, that's fine. So Dikshita said she cannot speak because she's traveling. That's okay. As long as you can understand and follow, it's fine. Now let's go to SAS. How about you, Advik? Can you explain me in English?
Side angle side means the angle at the top and the two sides. The angle between the two sides at the top.
It doesn't matter. It can be at the bottom also. If I have this side and this side matching, this side and this side matching, and the angle between them. See, it just talks about the two sides and the angle between them. Regardless of whether you're picking the two sides from the top or on this side or this side. It has to be two sides and the angle between them in both the triangles. Yeah? Arav, last one.
I really don't know about the fourth one, but what I know is that both of them has to be like a right angle. So
No, Advik, no. That's fine. Let me. Okay, so you don't remember that. That's okay. I'll cover it one more time. Anybody else in the class? Bhuvan, whoever has not spoken, Vasundhara, Tanu, Advik, hands down. You have already spoken. Everybody, I'll give a chance to everybody. Gidesh, you already told already. You have to put your hands down. Anybody else? You already got a clue which Arav gave, saying that this is for right angle triangle. Yep. Okay. No, Gidesh. No. Advik or Gidesh, no. I'm just trying to see. Yeah, Pranav. Yeah, Pranav has already spoken yet. Already. Okay. Fine. Okay. I will let Advik speak. Yeah. Okay. Let Advik complete. Yeah. RHS. What does it mean?
It means right hypotenuse side for only a right angle, because if the hypotenuse matches for a right angle for two congruent right triangles, then it matches.
Okay, I will put that in a more simpler form. The last theorem is for, first three theorems were for all possible triangles. All possible triangles. Regardless of their type, whether they are equilateral, isosceles, scalene, acute angle, right angle, whatever. These three theorems hold true for any type of triangle. But this one is for right angle triangle. This R stands for right angle triangle. And then hypotenuse and a side. Meaning, if you have two right angle triangles, they will be congruent. See, this is for right angle triangle, okay? R is for right angle triangle. So it says, if you have two right angle triangles, meaning this is 90 degree and this is 90 degree, and hypotenuse are same, meaning this hypotenuse, they are same, and one of the side is same. Let's say this side is same. Then these are congruent. Or you can also say, okay, if this side and this side are same, then also they are congruent. So this gives you a situation or 4 possible options based on which you can find out if the two triangles are congruent or not. Okay. Now I will tell you guys why I jumped onto the congruence theorems, and I have still not proved those theorems. Okay, I just made you guys recall them. In one of the class I will again prove why these theorems are even valid, because any theorem that you come across in math, it holds no water if you don't know how that has come into existence. And that's why I explained the derivation of the theorems as well, but not in today's class. We'll just look at why this theorem was important for us. Okay. Now let's look at a situation like this. I have a right angle triangle. Okay. I just told you guys about what is area, what is perimeter, and that was just I call it blabbering. I just told you what is the concept behind. I did not tell you how to find the area, correct? Now I'm going to tell you that, and that theorems were needed for coming to that point. Now, do I know what is the area of a triangle? I don't know it yet. So, this is my right angle triangle. What I will do is, I will extend this line which is parallel to this line, okay? And then I'll extend this one point which is parallel to this line. And it meets here. Let's say this was ABC, was my triangle, my right angle triangle. And I extended this point parallel to this line and extended this point parallel to this line. And they met at a point called D. Now if you look at it carefully, I mean my drawing skills are not great. That's why it might look little confusing, but bear with me. Now this has made a rectangle for us, isn't it? Because this was 90 degree, I made this parallel to this. So this is also 90, this is 90 and this is 90. So this is a rectangle actually. And if you look at it carefully, ignoring my drawing skills, if I do a better job this time, now this right angle triangle looks like, you know, this one and this one both are same. So this right angle triangle is half the area of this whole thing. So this area looks same actually. Yeah? Visually also, does it? It looks the same because if you look at a rectangle, you know the area of a rectangle is length times width. And again, when we come to rectangle, I will prove that one more time. But area of the rectangle is length times width. Now here when I look at this triangle, right angle triangle, by extending these 2 points, I eventually made a rectangle which is 2 times the area of my right angle triangle. By extending this, I made a rectangle which is 2 times the area of this thing. Meaning this triangle and this triangle both have same area. And when we come to rectangle, I will prove that one more time. But for now, visually if you see, this is half of the total area. So if the area of my rectangle is length into width, or if I say this is base and this is height, let it be width. Area of this right angle triangle will be equal to half of this total area. So half of length into width. Here, this is not a width. In case of triangle, you don't have a width. This you can call as a height. This is the height of the triangle. So you can say this is the height. And here when you say this is not length, in a triangle concept, this is called base. It's like your triangle is lying on this base. So half into base into height. That becomes the area of a triangle. So area of a triangle is half into base into height. So I know time is up. This is sending me reminder after reminder. I'll just take 2 more minutes and then we'll conclude. Okay. So from this one, we can say that if I have a right angle triangle, its area area of right angle triangle is half into base into height. Okay. We'll probably stop here. We'll not extend this class further. Otherwise, you guys will get tired. I'll be dumping on a lot of concepts in one day, and then that becomes a perfect candidate for forgetting things. So we just looked at what are the basic properties. We looked at how do we go from one line segment, rays to angles, angles to triangles, and then we looked at the properties of triangles. And we understood what do we mean by area and perimeter. And then we just looked at a right angle triangle and found the area of a right angle triangle is half into base into height. This is what will become our base to derive the generic formula for area of a triangle is half into base into height. With that being said, I will stop here. We revised theorem of congruence also. So we'll stop here. Whatever we learned, if I spoke very fast, something that you guys could not catch up, there's a video of the class that will be uploading in a little bit. You can use that also for your reference, for your revision. And then we'll resume from the next class. Yep. Alright. Ritika, was that a good jump start for whatever you wanted to learn?
Yeah, I already started learning. I just wanted to get some. I already started learning from this year, from earlier grades too. So
Right. No. So these are the base. These are the base. These are the foundation actually. Yeah. Okay. So now what we will learn would be a new thing for a lot of kids in this class also, because they have not gone beyond knowing what we talked about. Okay. So that's why I skimmed through it very quickly. And the next class, now when we pick up the concepts one by one, you will see new things getting added to what you know already. Yeah. And my request to you would be, Ritika, if there's any particular thing within geometry also that you would want me to pick up first, just send me a text message through Mommy's number. I will be able to pick that up in the next class. Yeah.
maybe some basic tricks. I started learning basic trig this year, but I'll do trig next year. So
Sure. Yeah. So we'll go in a flow, but and we'll try to make it as interesting as possible. But if there's something that you would want me to pick up first, just let me know. Yeah.
thank you.
All right. So I'll let everybody go. Enjoy the super.